All right, good afternoon, everyone, and welcome to AWS Security Reference Architecture Visualize Your Security. As many of you know, AWS has a growing and expanding suite of security and security-related services, and over the time we have heard from our customers how much they appreciate the detailed information available through our service documentation, blog posts, summits, conferences, tutorials, and so on. However, we have heard also the feedback that while they value the resources available for each individual service, but they would like to get more of a strategic view for the different AWS security services and how they can work together. Specifically, they asked for 3 priorities. Number 1, the recommended patterns for how they can holistically configure, deploy, and operate the different security services across multiple accounts and organizational units to meet their security objectives. Number 2, well, getting some sort of logical perspectives on organizing AWS security services beyond their individual functions. So thinking about it in a way such as organizing it in layers of protection. And number 3, with too many security services around, how we can integrate it together in the most effective way. Having a service such as AWS Config works perfectly fine on its own, but how we can integrate it with other services to achieve automated auditing and so on. And to address all of these challenges, we created the AWS Security Reference Architecture, which I'm going to refer to throughout our session today as the AWS SRA. This SRA provides you with some sort of a proven guidance that can help you architect and operate security while being aligned with the AWS recommended practices. My name is Mohamed Wali, and I work as a solutions architect at AWS, mainly acting as a technical advisor for enterprise and retail customers within Benelux, helping them in their journey towards AWS Cloud and while working on AWS Cloud. So what are we going to talk about today? Well, first off, I'm just going to give you a bit of a high-level introduction of what the AWS SRA is, how it can help you in different ways. And since the material and the content of the AWS SRA is quite rich and too much, we won't be able really to cover every single piece of it throughout the session. So we will highlight the key elements that are most relevant to you. Next, I will navigate you through the code library of the solution. So this solution doesn't only offer an architecture and recommendations, but also it comes with a code repository that can help you to deploy the solution. And finally, we'll take some time to go through a demo to show you how you can deploy the AWS SRA step by step to see how it works in action. By the end of the session, you will have some sort of a solid understanding for how to use and how the AWS SRA works, and how it can be used as a strategic blueprint to deploy, configure, and manage AWS security services in a multi-account environment. That being said, what is the AWS SRA? So the AWS SRA is a holistic set of guidelines for deploying the full complement of AWS security services in a multi-account environment. It actually can help you design, implement, and manage the different security services so that they align with the AWS recommended practices. The recommendations are built around a single-page architecture, which you can see on the left side, which is actually covers pretty much all of the AWS security services in different accounts. This document covers how they can interact together, where they should be best deployed and managed, and how they can help you achieve your security objectives. The recommendations and accompanying architecture are built from our experiences working with AWS enterprise customers. And eventually, we collected that and written it in a document that we have published in AWS Prescriptive Guidance, which is actually a link that I'm going to share with you later on. This document can be considered as a reference with a comprehensive guidance for how you can use AWS services to secure a particular AWS environment. Besides that, there is also an AWS SRA code repository. This code repository contains some ready-to-use infrastructure as code modules that can help you to deliver multiple solutions and multiple pieces that can form as a full AWS SRA. So you really don't have to start and build everything from scratch. So how the AWS SRA can help you? Well, the AWS SRA can help you in many different ways, depending on where you are in your cloud adoption journey. In particular, I'm going to cover 5 ways. The first one is it can help you to define the target state for your own security architecture. So whether you are starting your cloud journey on AWS by just spinning up a few AWS accounts, or just trying to enhance and establish AWS environment, the AWS SRA can be a good place to help achieve your security objectives. You can just begin with comprehensive foundation, which includes account structure and some security services. And then you can adjust based on your particular technology stacks, skills, compliance needs, and security objectives. But if you know from the beginning that you will be launching and building more workloads and applications in your environment, you can just take a custom build or a custom version of the AWS SRA and use it as the basis for your own organization security architecture that you can continue build on top of. Number two, it can help you to review and revise the designs and capabilities you have already implemented. So if you have security designs and implementation already in place, well, it's worth taking some time to compare what you have to what the AWS SRA offers. The AWS SRA is designed to be comprehensive and provides you with an agnostic baseline to review your security designs. Where your security designs align with the AWS SRA best practice, fantastic. You can feel more confident that you're following the AWS recommended practice. However, if you diverge or disagree from what the AWS SRA offers, that doesn't necessarily mean you're doing something wrong. Instead, it can be an opportunity for you to review your decision process and see why did you follow this path instead of what the AWS SRA offers. In fact, I have seen some legitimate business and technology reasons for why you might deviate from it after all. Number three, it can help you to bootstrap the implementation of your own security. So security requires a huge investment when it comes to building a security architecture, and we're trying to take the burden off your shoulders by providing you with an SRA code repository that can provide you with a fast and reliable way to deploy some of the pieces that form the SRA, so you don't start everything from scratch. Number four, it can help you to learn more about AWS security services and capabilities. So the AWS SRA documentation includes some guidance and discussions that covers different important security features as well as deployment and management considerations about the different AWS security services. One feature that I would like to refer to is when it covers the high-level overview about the breadth of the different security services and how they can work together in a multi-account environment, which kind of align with the priorities that were shared with us by our customers. Number five, it can help you to drive a discussion of organizational capabilities and responsibilities for security. So one of the most important key elements when it comes to designing a security architecture or a security strategy is to understand who in your organization has which security-related responsibilities. For example, the question of where will we aggregate and monitor the security findings is tied and associated with the question of which team will take care of that activity. Will there be a centralized team for which we need to push all the security findings in a centralized account and grant them access over it? Or are the application teams going to take care of that part and therefore needs access to the right monitoring and alerting tools? So these kind of questions and conversations can help you to identify the different security responsibilities across your organizations and define who are the stakeholders for every piece of it. So that being said, let's take a look at the architecture and the components that forms the AWS SRA. The AWS SRA aligns to three security foundations: the AWS Cloud Adoption Framework, the AWS Well-Architected Framework, and the Shared Responsibility Model. In case you're not familiar with the AWS Cloud Adoption Framework, it's simply meant to help you leverage AWS experiences and best practices to digitally transform and accelerate the business outcomes through the innovative use of AWS. It consists of 6 perspectives, and one of these perspectives is about security, and that's where the AWS SRA aligns to. The same for the AWS Well-Architected Framework, which kind of helps you to understand the pros and the cons of the decisions you make while building systems on AWS. The Well-Architected Framework consists of 6 pillars, and one of these pillars is also security related. As you will see later on, we're going to talk about one of the design principles of the AWS Well-Architected Framework and how the AWS SRA can help you to achieve that principle. And last but not least, the shared responsibility model. So when it comes to managing services on AWS, it's usually a shared and joint responsibility between ourselves and the customers. So depends on the service and to what extent AWS manages it, but talking about a service such as Amazon EC2, AWS takes care in that case for securing and managing pretty much everything from the layer of hypervisor all the way down to the security of the facilities in which the services operate. But on the other side, as a customer, you'd be responsible for patching the operating system, encrypting the instance, and restricting access to it by restricting the applied security group and that's attached to it. But eventually, we don't leave our customers alone in the journey, and we make sure that most of the time there is a tutorial, there is a service documentation somewhere that details how you can secure a particular product. So when we look at the AWS SRA on its high-level account structure, you can see on the left side that on the top of the diagram, there is the AWS organization. That's how any organization for any customer looks like. One organization that includes one or more organizational units, or OUs. Within these organizational units, you can see some specific accounts. By default, or according to our design, there are three organizational units, or OUs: infrastructure OU, security OU, and workloads OU, which I'm gonna cover later on and talk about the dedicated accounts that works within these OUs. The account structure that you see here is actually derived from our own experiences working with our customers, and it's based on the AWS organization's guidance and multi-account strategy that you can see on AWS documentation. The AWS organization guidance simply helps you to understand how you can manage and organize your accounts and your OUs in your AWS environment. And the multi-account strategy dives deeper into the different types of OUs and accounts, and what are the ones that we recommend you to have, and for which purposes. So this is exactly what we used here while we were building the AWS SRA. So this is a bit of a diagram that includes pretty much all of the services allocated to the different accounts, but I know it's hard to read. That's why let's break it down into pieces and walk through it one by one. So the first OU I'm going to talk about is the security OU, which contains two accounts as part of this architecture. One of these accounts is the security tooling account, or the audit account. This account is dedicated to operating security services, monitoring AWS accounts, and automating and responding to security incidents. Pretty much all the services you see in this diagram are the ones that are responsible to help you to do so. So for example, if we look at a service such as AWS Security Hub, as we see here, the AWS Security Hub is one of the services responsible to conduct automated checks against industry-aligned and regulated frameworks. But beyond that, it can also integrate with other AWS security services to pull their security findings and centralize it in the same place. So if we talk about a service such as Amazon Macy, which is an AWS service that helps you to detect sensitive information available in your Amazon S3 buckets, it's going to send its findings to AWS Security Hub. The same for Amazon Guard Duty, which is going to help you to detect malicious activities in your environment. Or AWS Firewall Manager, which can manage your security group roles, network firewall manager roles, WAF roles, and so on, organization-wide, and let you know if there are non-compliant security groups or any of these other resources. And AWS Config, which can help you to detect any changes in your resources, which simply can help you to make sure that your resources are in compliant state or not. It's just a detective service, but it's going to notify you. So eventually, these findings would be sent to the AWS Security Hub, and for further investigation and to dig deeper and dive into all of these security findings, you can use Amazon Detective, which is one of AWS security services that provides you with a data visualization, where you can dig deeper into the security finding to get to know its root cause. So this is just an example for how different security services can work together and where they should be allocated. In this case, they work organization-wide. They would monitor and get the findings from pretty much all of the other similar services. Like if we're talking about Security Hub, it's going to get its findings from Security Hub from the managed accounts on the organization as well. Later on, I'm going to show you an example for how an application account would look like and how it streams these events to the centralized security tooling account. The other account in the security OU is a log archive account, and this account is dedicated to ingesting and archiving all security-related logs and backups. With a centralized log in place or putting it in a place such as S3 bucket, where you're getting the different security logs, such as the flow log, the VPC flow logs, which kind of log pretty much the accepted and the rejected traffic in your VPC, or the CloudTree logs, which captures the API activities within your AWS environment, or the DNS logs and the X logs and so on, would be centralized in one S3 bucket in the log archive account. And by having these logs over there, you can actually monitor, audit, and alert on Amazon S3 object access to know if there is any undesired access towards this S3 bucket, if there is any IAM identity policy changes that grants access to other people, access to it, and any other critical activity that might impact accessing these kind of sensitive resources. Some of the services such as Amazon CloudTrail, as I mentioned, sends its logs to the log archive account, that's where to archive it, but they also work across the different accounts in your organization to collect and aggregate the logs from them. The second OU we have is the infrastructure OU, and it also contains two accounts. One of them is a network account, and the network account here is kind of managing the gateway between your applications and the broader internet. So it's quite important to protect this two-way interface. The network account would help you to isolate your networking services, configuration, and operation from your application workloads, security, and other infrastructure. So this kind of arrangement helps you to not only to limit connectivity, permissions, and data flow, but also to support separation of duties and providing least privilege to the teams that needs to access these accounts. It consists of multiple different services, as you see, where different services can help you with different functionality. Some of the services you see below, like Amazon Guard.AWS config, these are more account level that aggregate their own findings and send it to the security tooling account, but the ones oriented to the network functioning are services such as the Resolver DNS firewall, the network access analyzer, the VPC lattice, and so on. The second account in the infrastructure OU is the shared services account, and as its name indicates, it's actually meant for services that can be shared and consumed by different applications across your organization. So think about, when you think about it, consider services such as AWS Directory Service, which is simply a managed Microsoft Active Directory on AWS, or any other messaging services that can be used by your applications across the different accounts in your AWS environment. The last OU is the Workloads OU, which contains an application account. This would be the different OUs you have in your organization, in which you're going to run your own accounts where your applications reside. And for the sake of showing you an example, we just have an application running over here on a handful of EC2 instances and uses Amazon Aurora as a database. Now let's see how we can apply security on our application account level. Well, we have 3 orange boxes, so we are starting from left to right. So on the left side, you see the AWS Systems Manager agent. And for many of the AMIs that AWS provides, the Systems Manager agent is already installed over there. But if you're baking your AMI or bring in some AMI, please make sure to install AWS Systems Manager agent, because apart from its rich management and operational features, which you're going to need for other stuff, but from security perspective, it's important as well. So the Systems Manager agent here can help you in 2 key operations. One of them is to patch your EC2 instances. So with using System Manager, you can create patching baselines and patching policies towards your Windows, Linux, and macOS-based workloads on AWS. Moreover, some security services, such as Amazon Inspector, uses it to run their own tasks. For example, Amazon Inspector can assess your EC2 instance to see if there are any vulnerabilities in your operating system, if it's hardened, if the image is hardened, and if there is any unintended network exposure. And in that case, it uses the Systems Manager agent to run these assessments. Moving to the next box, we see multiple endpoints. And in case you're not familiar with the concept of VPC endpoints, it's simply a way to provide your resources residing in one of the Amazon VPCs to get some access to AWS managed services using the backbone network of AWS without having to go through the public internet or without having to establish any VPC to VPC connectivity or doing any extra effort to manage networking on that level. You can restrict the endpoints as well, not only by granting access to these managed services, but also by using their endpoint policies that can restrict what kind of actions that can be done for the traffic flowing through this endpoint. And you can set up some security groups that can restrict which other security groups or which other IP addresses you would like to allow them to send their traffic towards this endpoint. All the way to the right side where we can see this bunch of security services, which works on the account level, and I can imagine that you have seen them already earlier on the security tooling account. So pretty much almost the same services that works organization-wide can also work account-wide. The thing is, in this case, it's dedicated to this account to give the application team enough security insights about how things look like in their account. But what you saw earlier in the security tooling account, that's more of an aggregation for all of the security findings in one account for one service. That can be used in the other case for security teams so they can track and manage and set up their own alerting and response over there. So before moving further, I just would like to pause and review what we have covered so far. We introduced the AWS SRA and how it can help you. Then we moved to the account structure of the SRA, the different OUs, the different accounts on them, and how they can help you, and what are the purposes of them, and how different security services can work together. So what we have covered so far addresses two priorities of the three we mentioned at the beginning. The recommended patterns for how you can holistically manage, deploy, and configure the different security services in a multi-account environment. So we see which security services should be assigned to which account and how they can be managed. And the third one, which is we have too many security services, how we can integrate them together, with the example of integrating Security Hub with other services in order to get the right security findings, and by integrating it eventually with Amazon Detective in order to dive deep into the security finding to get to know the root cause. Next, I'm going to talk about the security at all layers, which is one of the design principles for the AWS Architecture Framework security pillar. And when we talk about security, most of the time we talk about defense on depth, which is the third priority that I talked about at the beginning. Well, you would like to get some logical perspectives on organizing your security services into layers of protection. So when you look at your AWS environment, you can see it in layers in that way. It all starts with the AWS organization at the top. That's your whole organization, and there are some things that can be applied organization-wide. Then the next layer is the organizational unit, where you can have one or more accounts, and that can be decided based on many decisions, such as the business unit, the application types, so on and so forth. And within this organizational unit, there will be the AWS account, so one or more AWS account where you are running your applications. And almost side by side, there is the network and content delivery layer, where you need to protect your networking within the AWS accounts, but also for your traffic that goes across AWS accounts. All the way down to AWS principles, and AWS principles are the fundamental element of identity and access management on AWS. And last but not least is AWS resources. So let's take them one by one and see how we can apply security at all of these layers. I'm just merging at the beginning the AWS organization together with OUs because pretty much most of the services that can be applied here can be applied there. So when you think about services that we talked about at the security tooling account at the beginning, such as AWS Config, Security Hub, Amazon Guard Duty, and so on, these can be applied organization-wide. They can aggregate pretty much the security findings from all of your accounts you have in your organization. This way, you can have a centralized team or centralized multiple teams that can address different security concerns. But there is also something like the service control policies, which can help you to restrict or define what can be allowed and what cannot be allowed within your accounts in terms of permissions and operations. The same for AWS Cloud Trail, which can help you to create an organization trail that would capture pretty much all of your API activities from the different accounts across your account, while also making sure that every account has their own account dedicated trail. So with SCPs, or service control policies, I would like to get back to it again, mainly because you can apply it on the organization level, but also on the organizational account level. It depends on how you would like to address it, but you can start with a bit of a more permissive permission set for the things that you know for sure they are not going to be used or allowed anyway, And then for every OU, you can actually go ahead and assign a bit of a more restrictive permission. The same actually applies for the accounts, because service control policies can be applied to the accounts as well. Maybe some accounts or one account in your organizational unit needs to have a bit more restricted permissions than others. So you still can use the SCPs or service control policies on the account level together with the other AWS security services that you have seen working organization-wide, such as AWS Config, AWS CloudTrail, Amazon Guard.t, AWS Security Hub, and so on. But beyond these organizational and account-based services, there is also some account-dedicated security services. Thinking about a service such as AWS Secrets Manager, which can help you to store and manage and rotate your secrets so your applications can just retrieve them without having to hard-code the secrets in your account. Or AWS Key Management Service, or KMS, which is another service that can help you to protect your resources at rest by encrypting them. There is also similar mapping at the network layer, where the networking part also needs to use some networking-related services which can help you to achieve network security, such as AWS Shield, which can help you to protect your resources in your VPC against DDoS attacks, or AWS Web Application Firewall, which can help you to protect your applications against not only DDoS attacks, but also you can control or whitelist or blacklist IPs and so on. On the VPC level itself, you can also still provide some security by using security groups, which are the basic things you can do, network access control lists, but also securing the VPC endpoints by making sure that you're restricting down the policies of the VPC endpoints and assigning security groups to them. You still can use flow logs in your VPC to track which traffic is accepted, which traffic was rejected, so you can also create, for example, if there has been a certain IP address trying to hit, I don't know, a certain service and it's getting rejected multiple times, potentially you would like to be notified about that. Moving down to the principles layer, and as I mentioned, the principle is a fundamental element of identity and access management, and it simply can be represented in the form of an AWS IAM user or group or rule or any basic thing like that. And you need to restrict down the access, starting off with the IAM policies itself that would be associated to any of these principles. So by making sure that you're following the least privilege principle, you need to make sure that you're not granting any permissive permissions to anyone. But also on the session level itself, when someone is assuming another role and it's being passed to it, by restricting down the session policy, it can make sure that the user that's going to assume this role would be restricted down with what they can and what they cannot do. There are also other AWS security services, such as AWS Directory Service, which is simply a managed Active Directory on AWS. And you might potentially be using that to create users for your applications and so on. You need to apply pretty much the same for the principles coming out of your AWS Directory Service. And finally, the resources layer. And the resources layer, well, when it comes to policies-based, it has something similar like principles. So you can apply or associate policies to principles, but on the resources level, you can create resource-based policies as well. Thinking about a service such as Amazon S3 or KMS or SQS, these services enable you to create their own policy, which can restrict what kind of activities that can be practiced against them. So make sure to utilize that as well and not to count only on the principle, because although the principles can help you to restrict down the access, but adding one more extra layer on the resource itself can make it even more restrictive. Other resources that can help you, something like AWS KMS to protect the resource by encrypting it, or AWS Config, which can always keep its eye on the resource itself to see if it's in a compliant state or not. That being said, let's see actually how we can apply the AWS SRA to the AWS security perspective capability, which is one of the perspectives of AWS Cloud Adoption Framework. So the first capability we're going to talk about is identity and access management, and it's simply meant here to help you manage your identities and permissions at scale. And there are two key services that you need to use at least in order to address this capability. The first one is AWS IAM Access Analyzer, which is simply can help you to identify unused access in your organization accounts and generates IAM policies based on access logs that are retrieved from your CloudTrail. And the same for if there is any AWS or AWS resources that are accessed by external identities. So this service, like the other services that you have seen in the security tooling account, sits and resides there. And from there, it manages and aggregates the findings from pretty much the whole organization and sends its own finding to the security hub. The second service is AWS IAM Identity Center, which is another AWS service that can help you to manage your identities at scale, while also integrating and federating with third-party identity management solutions, such as Okta, such as Microsoft Active Directory, or Microsoft Entra ID, formerly known as Azure AD. The delegated admin account for the AWS IAM Identity Service, though, is shared service account because that's where usually the Microsoft Active Directory service resides. Simply, we would like to keep both of them at the same account because sometimes if you are operating them at different accounts, there can be some limitations in terms of the capabilities you would like to achieve, especially if you are integrating them together. As a design consideration, though, we have seen some customers who they have their own identity and access management team. If that's the case in your organization, feel free to create a dedicated account for IAM where you're hosting your identity management and identity-related services, such as AWS IAM Identity Center or AWS Directory Service for Microsoft Managed Active Directory and the other identity-related services. The second capability I would like to talk about is detective control. And when we talk about detective control, it actually goes hand in hand with incident response, which I'm just going to talk about it afterwards. So detective control, which can contribute to threat detection in a way, can help you to understand and identify potential security misconfigurations, threats, or unexpected behaviors. Pretty much these four services contribute to this capability, starting with the AWS CloudTrail, AWS Config, AWS Security Hub, or Amazon Guard Duty, because all of them can generate events about something happened, which you need to use in order to detect if there is any security issue happening somewhere. Pretty much all of them resides in the security tooling account, except the CloudTrail logs, which goes to be archived in the log archive account. Eventually, as you have seen earlier, all the security findings spread across the different accounts would be aggregated and stored into these services in the security tooling account. As a design consideration, though, we have seen some customers who have multiple security teams. And if that's the case in your organization where different security teams are taking care of different stuff with different responsibilities, you don't really have to allocate all of these services to one centralized security tooling account, but instead you can create more than one security tooling account that aligns with the different team responsibilities, and then from there you can grant them access to what they need. The same also applies for monitoring and responding related services. And speaking of monitoring and responding, now we have detected the problem, we have detected the issue, we need to react. And that's where the incident response capabilities comes into play. So the incident response can help you to reduce the potential harm by effectively responding to security incidents. So now you detected the problem, you need to get some sort of automation to plan for your response. For example, if we talk about a service such as AWS Config, which might have detected a non-compliant resource in your AWS environment, you can integrate it with another AWS security service, such as AWS Lambda, which can just go ahead, once this resource is put in a non-compliant state, it's going to take an action to remediate it from this undesired state. However, we do recommend you by any means to have a playbook ready in place for planning for these, to plan for these responses. And we do have plenty of these playbooks available in AWS documentations, which I'm going to share with you its URL later on. Last but not least, now you have, or trying to react to the incident, you would potentially interested into investigating further into the issue to get to know what's the root cause. And that's where Amazon Detective can help you. So Amazon Detective, as I mentioned earlier, give you some sort of a data visualization for the different security findings coming out of Security Hub or even right away from Amazon Guard Duty. So you can just dig deeper into them and get to know what is the cause of this security finding. Like the other services, this service as well resides in the security tooling account. Now we managed to set the guardrails in place. We managed to plan for our event detection, threat detection, and response. we need to go one more layer up. We need to protect our infrastructure. We need to make sure that our network has some sort of defense in depth. And that's where the infrastructure protection capability comes into play. So with infrastructure protection, there are a few things to consider here. One of them is the VPC security, and with VPC security, there is a defense in depth that can be applied, as you have seen earlier, by just making sure, starting from the resource itself, you are applying a security group right away on the resource level, but then also a NACL on top of it, a network access control list, using VPC endpoints and restricting them with policies and security groups and so on. But beyond the VPC simple functionalities, you can also use a service such as AWS Network Firewall. And AWS Network Firewall can help you to manage and control the traffic going from and to your VPC towards the AWS NAT gateway or internet gateway, which are simply services that helps your resources to go out to the internet. On top of that, it can also control the traffic between your VPC and other securities or your other resources located somewhere else, which has to go through a VPN or has to go through a direct connect. In this case, can be your on-premises environment. What you will see in the AWS SRA documentation is we are just doing a centralized deployment for the AWS Network Firewall and the network account with the transit gateway. However, as a design consideration, if you are having a decentralized deployment for AWS Network Firewall, where you're deploying it in different accounts, then at least make sure to have an AWS Firewall manager centralized in the network account to set some sort of rules in a centralized way to make sure that the different services are compliant with that kind of baselines across the different environments and the different accounts. The last capability, the fifth capability I'm going to talk about is the vulnerability management. And now we managed to protect our network. We need to protect our endpoints as well. So to protect your endpoints, there are two services that can help you at least here. One of them is AWS Systems Manager. As we have seen earlier on the application account, we need them for protecting against vulnerabilities by using Amazon Inspector, which can just go ahead and use the AWS Systems Manager agent in order to evaluate the EC2 instance against the vulnerabilities on the operating systems and the AMI, as well as the unintended network exposure, but also to configure and deploy the patches to your EC2 instances. And for that, you can use a capability of Systems Manager called Quick Setup, which can apply organization-wide, so you can some sort of get an inventory for all of your EC2 instances across your whole AWS organization, and from there, you can create different patch policies and patch baselines and apply them to the right ones accordingly. The AWS Systems Manager sits in the shared services account to manage pretty much the whole organization. The other service is Amazon Inspector, which I quickly covered, and it also sits in the security tooling account, and it's going to send its findings to the security hub eventually. But so far, I have been talking about Amazon Inspector as a service that can actually help you with EC2 instances, but it also supports other AWS services such as AWS Lambda and Amazon ECR, where you're hosting your container images. The last capability we're going to talk about today is data protection. And when it comes to data protection, you always think about how you can maintain visibility and control over data. So how it can be accessed and used in your own organization. And talking about data protection also brings the topic of data encryption at rest and in transit. And that's what I'm going to talk about for the first two services. The first one is AWS KMS, which is one of the AWS security services that can help you to encrypt your resources. We do recommend to deploy it in a decentralized way, where every account and management and application team has their own AWS KMS keys. So it's easier for management, and it's in the same account without the complexity of cross-sharing things. However, we do recommend to get some sort of governance and monitoring in place via a centralized team, which can be a platform team, a security team, and so on. The reason here is you don't want everybody to just go ahead and delete an encryption key, which can happen mistakenly. And also, you'd like to keep your eye on the KMS keys events. For example, if somebody or if you have noticed that there has been an event happening over and over again, that somebody's trying to decrypt the KMS key, but it's failing, you would like to be notified in case such a kind of activity is happening. Although the application team would be taking part of the responsibility, but having a centralized team watching out for these things would be even better. The other service is Amazon Certificate Manager, which can help you to protect your traffic in transit. And Amazon Certificate Manager provides you with public certificates and private certificates. Public certificates can be deployed to the normal workloads and application accounts, so they are close to whatever they are trying to help with. But the private certificates, we do recommend to have some sort of a centralized certificate authority in place in a centralized account managed by one of the security teams. And then it can be shared with the different accounts using Resource Access Manager. From there, you can grant the different teams the needed permissions to create the certificates themselves. So you offloaded that part of managing a gigantic certificate authority hierarchy from them, but also while granting them the needed permission to get the certificates they need to protect their internal traffic between the different services and applications. And the last piece of data protection is Amazon Macy, which, as you learned earlier, it helps you to detect if there are sensitive information in your Amazon S3 buckets. It's quite crucial for some organizations, especially who are trying to provide a way or a mechanism for data loss prevention. Because in this case, getting to see some PII data in an S3 bucket, that really doesn't sound nice. So that's pretty much it for the different ways that the AWS SRA aligns to the different security foundations and how it can help achieve different security objectives. In the next section, I'm gonna walk you through the AWS SRA code repository, which actually gonna show you what the AWS code repository has and how you can use it. So these are some of the current available code examples for the different services that are ready to use. You don't really need to build any of these. You can just go ahead and reuse its infrastructure as code module to build it right away. It's available in CloudFormation. So if you are a Terraform fan or any other infrastructure as code tool fan, well, we don't support that for the time being, but feel free to build it from scratch if you'd like. So these are the ones we do support for the time being, but we are always happy to hear your feedback about that. Beyond the different security services we have covered, there are also some account-dedicated configurations which can help you in your security objectives, such as configuring an IAM password policy for your different accounts, having an Amazon EBS default encryption to make sure that any EBS volume you are associating to any EC2 instance you have in your environment is already encrypted, and blocking the public access to Amazon S3 buckets. This is how the GitHub repo looks like. It's meant to be self-service, pretty much well-documented. All the step-by-step guide you may need to implement it is already there. It's focused on AWS Control Tower environments, and it provides you two ways for implementation. One of them is just by using CloudFormation templates and deploying it in a stack set for different accounts in different regions, or an easier way by just using the customizations for Control Tower solution if you already use it. As I mentioned earlier, it's built from our AWS experiences, so these are really some work that we have delivered to some enterprise customers before. It has properly tested, and it's live in some of the production environments of some of our customers. What else is included? Within the repo, you would see different directories for the different solutions that forms the AWS SRA. You'd be able to see that for every solution, there is an architecture diagram, talks about the different resources we're using in order to deploy the solution in that way. And for every resource you see, there would be a description, what it is and why it is there, associated with the deployment instructions for every solution you have. So if you'd like to deploy just one or two solutions in a custom way, feel free to just go ahead and get it and deploy it yourself. It's done in a least privilege way, so IAM permissions is done after multiple security reviews, following the least privilege principle. And eventually, once you're done with deployment, you should be able to see some post-deployment events to verify that your deployment has gone successfully. So before going to a demo, I just would like to show you this architecture flow. This is actually, if you're using the easy setup for the AWS SRA, this is exactly how it's going to look like. You're going to start off at the top of the diagram with just an AWS CloudFormation template called SRA-EG, the setup that you can get from the SRA code repository. Once you deploy it via the CloudFormation console, it's just going to go ahead and create an AWS code build project. This code build project, that's where most of the magic happens. It's also going to go ahead and create an AWS Lambda function that would act as a custom resource, which would be invoked by the AWS code build while it's running to execute other stuff. Then it's going to also deploy an AWS CloudFormation stack, and this stack simply at the beginning and for the first time just going to go ahead and deploy an Amazon S3 bucket. This S3 bucket we call the staging bucket. That's where you're adding pretty much all the AWS SRA code that you're downloading from the GitHub repo that would be used by the different services in order to get deployed. Once the S3 bucket is provisioned, it's just going to go ahead via the code build project and download the AWS SRA GitHub repo locally in the code build project itself, and then upload it to the Amazon S3 bucket. Once the code is there, once it is uploaded, it's just going to go ahead and deploy 2 CloudFormation stacks that builds what we call the common solution. So the common solution is simply a solution that includes the prerequisites and the foundations for all the other security solutions that would be needed later. So this is a one-time thingy, and later on it would be just go ahead and jump to the last one, which is the CloudFormation stack for deploying the different AWS security services that you would have. So that being said, it's demo time, and let's take a look at how actually we can install the AWS SRA solution step by step from the code library. So this is a management account, the very first account in your organization. We are having a control tower landing zone already in place. And in this control tower environment for this landing zone, we have 2 OUs and 3 accounts. And as part of our configuration, we're just governing 4 regions only. US East 1, US East 2, US West 2, and US West 1. So this is just to give you a bit of an idea about the landing zone that we already have in place before we build the AWS SRA solution on top of. So now I'm just going to navigate to the management console, and from there I'm going to navigate to the AWS SRA GitHub repo to start downloading the code. So by moving to the AWS SRA GitHub repo, you can see in the table of contents that there is a section for AWS SRA Easy Setup, and from there you would see a hyperlink that can guide you for the AWS SRA Easy Setup directory. That's what you need to navigate to if you'd like to follow the Easy Setup way, not the custom way. And over there you would see in the table of content of this directory the link that you can use to download the Easy Setup CloudFormation template. You can just go ahead, copy it, and then you can open your command line and paste it over there, and from there it's just going to be downloaded locally. If you're using AWS Cloud Shell, that can be also a thing, so you don't necessarily have to download it locally to do it. Sometimes you can just spin up an AWS Cloud Shell and download it over there and deploy it from there. Now we're just going to go ahead to the account and open AWS CloudFormation service. And before I start deploying anything, we need to go to stack set section in order to activate trusted access. So that's a prerequisite for all the other work we're going to do later on. So you're just going to hover over it and click on it. And once it is activated, just takes a few seconds, and you should see it on top of the page in green telling you that it has been successfully activated. Now we're just going to go back to the stacks section where we can create our CloudFormation stack for the CloudFormation template that we just downloaded for the SRA Easy Setup. So we're going to click on create a new one, and then we would like to upload the template file because we have downloaded it locally, and we're going to browse for it, select it, and then we can proceed from there. It's called already SRA-easy-setup.yaml file. And the next interface, that's where you need to specify the stack details, starting off with the stack name. You just need to provide something descriptive, and then you can specify and configure the parameters in a way that meet your needs. So pretty much all of the parameters, or most of them, are pre-populated, as you see. But what we would like to focus on this demo is that the fact that all the services have the no option by default, which means no of these services would be deployed. So we need to select the services that we would like to deploy in order to deploy them with AWS SRA. In this case, we just choose the AWS config management account and AWS Cloud Trail. But no matter what we are choosing, the common solution would be deployed anyway once we use this CloudFormation template, because that's the core and the basic stuff that we need to have in place before moving any further. You can continue scrolling down if you would like to change the parameters of specific to the security service you have chosen. Well, for the time being, we're just going to keep it as is. but feel free to look at them. Pretty much all of them doesn't only has title, but also a description about what this parameter is about, so you can change it accordingly. And by navigating all the way down and moving to the next screen, this is the last screen where we have the different parameters that we have chosen and configured so far. All you need to do is just reviewing it and then acknowledge IAM resources creation and capabilities auto expand, and then click submit to launch the service itself. So what's happening now is the CloudFormation stack is launched, and it's trying to create the AWS SRA services that we have selected. On the left side, you can see that we have different stacks, and that's where you can track the different nested stacks that would be created out of this one over the time. While on this pane, you can track the events for your CloudFormation template. When we look at the our diagram initially, at this stage, it's actually creating the code build project, comparing to what we see on the events here. And once it's done, it's going to go ahead and create the Lambda custom resource. And then from there, just going to go ahead and get back to the code build project to deploy the CloudFormation template that would just deploy the S3 bucket, which is the staging S3 bucket. This is the one which is also fundamental part of the common solution. This was the design of the common solution. And once it is deployed, it's just going to go ahead, invoke the API of GitHub to download and clone the GitHub repo of SRA and then upload it to the Amazon S3 bucket. Once we have the resource there, it's just going to go ahead and proceed to the next two CloudFormation stacks related to implementing the common solution. So the common solution, as I mentioned, have two stacks to deploy the needed prerequisites for the AWS SRA. And once the common prerequisite solution is installed, which will just happen as we track the events, it's gonna go ahead and start deploying the services, the AWS services that we selected to deploy. These two services that we selected in the parameter console were the Security Hub and the config, AWS config management account. So that's what it's trying to do at this stage. And as we see, we can track the different stacks. On the left side, we see that some solutions are done already, like the common previously, and that deploys pretty much all of these different resources that are part of the common solution. And it's afterwards, it's configuring the Cloud Trail solution as well as the config management account solution. So it's going to take a bit of some time, and all you need to do is just waiting and watching. Eventually, while you're actually deploying it, it's going to take a really long time, probably more than an hour or something. But just keep your eye on it, track the events to make sure that everything is going as expected. At this stage, it's deploying the AWS config. If you'd like to know what's going on, also you can open that architecture for every solution you're deploying on another screen, watching for which resources are being deployed and configured, so you know if it failed somewhere, you know exactly what to do or what to address. So that's pretty much it. It just managed to deploy pretty much the whole stack together with the two key services, the AWS Cloud Trail solution and the AWS config management account solution. And as we see on the events status, it sounds that everything went quite well. The status is create complete. The same for the stacks on the left side. And if we navigate back to the stack console, we see that many nested stacks has been created out of that original one, and all of them are in create complete status, which is exactly what we would like always to see. Now, what if I would like to update the AWS SRA? What if I would like to install more solutions? And that can happen because I would like to install and configure the AWS Security Hub, for example. In this case, I just need to go back to the AWS CloudFormation console and then search for the AWS SRA Easy Setup stack. We managed to find it, so we just need to select it and then go ahead and update it from the button up there. And from there, it's pretty much straightforward in terms of the options you need to choose and select. Just keeping everything as is at this stage. We don't want to change the stack that we have initially selected. All we need to change is actually the parameters in the next console. And in particular, we need to choose another service that we would like to enable and configure. So we're just going to go ahead and scroll a bit down to the Security Hub solution, select yes, and then scroll all the way down unless you would like to change any of its own custom parameters provided down there. And then gonna go ahead and click on next to do any stack related configurations if needed. And from there we can just review what we have done, and voila, we can just scroll down and submit it. So that's how easy it is also to go ahead and update the AWS SRA solution. It's a bit of actually how to use what's in there. The moment you familiarize yourself with it once, the next time you go ahead and update other solutions or do other things, you would be already familiar with what's going on, given that you have logged many times at the events going here, knowing the stacks that would deploy these solutions, also by getting the design on your side, by looking at it all the time, trying to say what's going on there, would also help you just in case something happened, especially if you have mistakenly, I don't know, deleted one of the S3 buckets used by them or the resources used by them, then you know what's going on. At this stage, it's just creating a couple of IAM configuration rules that would be used by the AWS Security Hub by just looking at the AWS Security Hub stack, and then it's just going to go ahead and create a Lambda function associated with different resources, and then enable the Security Hub in the audit account, while also enabling it for pretty much all of the accounts you have in your AWS organization. And once it's done, it's going to go ahead and start to update or clean up the update progress that has happened so far. So what we see now is it's actually, yeah, update has been completed successfully on the events-wise. But sometimes, if you actually look on the left side, you can see that on the stacks level, sometimes it can be a bit laggy. So all you need to do is just to, if you find it completed on the events but not on the stacks status side, just go ahead and refresh it, and it should just reflect the latest status to it. And as you see now, after refreshing, it sounds that update has been completed successfully and everything went fine. Since we have now enabled Security Hub, I just would like to confirm that Security Hub has been enabled and configured successfully. So I'm opening one of the member accounts in the organization and navigate to the Security Hub console to say if Security Hub has been enabled in that account already. And as you see, Security Hub sounds to be loading perfectly fine on one of the member accounts with a security score of 88%. So that's exactly what we want to make sure that the different member accounts also have Security Hub enabled. But when we go to the delegated admin account, the audit account, or the security tooling account, that's where we can also verify that Security Hub has been installed and configured. And also we can have a look at which member accounts in our organization that are being managed by this delegated admin account from the settings console. And we have just a couple of accounts here that are actually being managed by this account. So that's pretty much it for the demo. To summarize what we have covered so far, make sure that you're planning your account structure by following the SRA recommendations, but keeping in mind the design considerations, like the ones I mentioned, where we're talking about the cloud adoption framework, security perspective capabilities. There may be some cases where you have a dedicated team like I am. In this case, you don't have to keep AWS security services in certain accounts, but instead it can align with what you have in your organization. Make sure to set up the foundation properly by starting to identify the core services. As we also seen earlier, like to do identity and management properly, we need two key services, IAM Access Analyzer and AWS Identity IAM Center, but potentially that can be accompanied with other security services such as AWS Directory Service or Microsoft Managed Active Directory and so on. And then you can identify where they should be deployed, and that should be based on what we recommend or based on what you have. Like if you have multiple security teams, you don't need to have a single dedicated security tooling account, and instead you can have multiple ones, and identify how your services can interact with others. And the others doesn't necessarily has to be the AWS security services you have seen today, but it could be third-party solutions as well that you have in place. Make sure to identify the additional services that you might potentially need depending on your infrastructure, and that can be non-security services, for example, services that can help you to remediate a non-compliant resource such as AWS Lambda to take a certain action and enforce this resource to be in a certain state. And deploy the identified services using the code library. It's going to save you a lot of time. You don't have to build everything from scratch. And at least you can use it as a basis for what you can build on top of to meet your organization's goals. Where you can find the resources we have talked about in the session so far, this is a QR code of the AWS Prescriptive Guidance. This is the document that goes through the details of all the pieces we have talked about so far, and the code repository as well. This is a GitHub code repo. That's where you can get the code to deploy the solutions. That being said, I really would like to thank you for your time today. I wish you a nice day ahead, and I would be around for the rest of the day if you have any questions. Thank you so much.